Greetings to you, my fellow humans. Very warm welcome to my third video. Thank you for tuning in. So in the previous two videos, I introduced the concept of DO-178C in plain text. Radical, I know. Um, but the point is the entire DO-178C project, so that's all the documents, the PSAC, the software development plan, the software verification plan, everything, and the source code, obviously, the test scripts, the reviews, the problem reports, everything is in plain text. So contrast this with what you might be doing at the moment with your DO-178C data buried indoors in Microsoft Word and Excel, PDFs, stuck in Polarian, random emails, scraps of paper. Plain text makes the entire project readable by the AI. It's searchable with powerful tools such as grep, ripgrep, fuzzy finder, and it's editable within your editor. For example, Emacs, using the org mode functionality that has, but it doesn't have to be Emacs. Vim has an org mode plugin. VS Code even has an org mode plugin. Um, so anyone can use it. In future videos, I'll showcase the different AI agents that we have created. But for this video, I just want to showcase a single agent, which is effectively a DO-178C expert that either a human user or even another AI can interrogate to unravel the mysteries of the certification process. So we call this agent the virtual DER. A DER is a designated engineering representative. So these are the people that serve as independent experts, and they ensure compliance with regulations, with standards, and with safety requirements in the aviation industry. The European equivalent of this is the design organization approval. So they're very important people. They sign off the safety of the entire system, very knowledgeable people. But just to be clear, this agent that we've created, it acts only as a local expert. It doesn't actually certify anything or even measure any compliance, but it is able to take the DO-178C standard and interpret it to provide guidance to the user. So I'll give you a quick demo of the virtual DER, quick overview first. So we've taken the standard, we feed it to an LLM, and that allows us to ask questions on the standard. So it's all command line at the minute, but we can ask some very specific questions. For instance, what is the difference between CC1 and CC2? Give references. So the answer is that CC1 and CC2 are two configuration management control categories that define the set of software configuration management process activities. These are very important in DO-178C. It's basically the source code control, the documentation control, and CC2 is a subset of CC1. The AI goes on to say that this is where you'll find more information, table 7.1, the Annex A tables. But unfortunately, without the actual context of the tables, it can't answer any more questions. That's because in this particular AI, it's unable to understand the tables. It can understand the text, but it can't interpret the tables. Just as a side note, it's not only the DO-178C PDF, we can give it any PDF. So we've given it ARM reference manuals and asked it, how do we disable the cache? So these local experts become very powerful tools that we can quickly interrogate and find out information that we're looking for. And these will become our AI agents, and there'll be multiple agents all talking to each other. So as I said previously, there was a problem accessing the tables, and this is an example of one of the DO-178C tables here, table A1 for the software planning process. And it defines objective descriptions, so a bit of text to say what that objective is. For instance, the activities of the software lifecycle process are defined. And it gives output data items. So these are the documents that you have to produce to meet that objective. And they're further broken down into the software level. So software level A being the most safety critical level, and D the least critical level. And when you do a DO-178C project, the eventual outputs of all the hard work have to match the requirements that are in the DO-178C document. You have to say for level D, make sure that you define the software lifecycle processes and that you have these 5 documents: the plan for software aspects of certification, the software development plan, the software verification plan, software configuration management plan, the software quality assurance plan. But say for level C or levels A to C, you also need to make sure that you have these 4 things. You need software verification results, you need coding standards, design standards and requirement standards. So we have cracked this. We've been able to get our AI to understand these tables by reformatting them into a more easily digestible format for the AI. And so we're able to ask it a question: what are the output data items that are applicable to software level D? So we're looking to see these 5, and we can ask it, say, for level B, then we expect to see these 5 plus these 1, 2, 3, 4. So we'll get 9. So for level B, we ask it and we get the 9 documents, the 9 bits of information that we need. And for level D, it's understood that we just need the 5. We can go and ask it a deeper question to pull out the descriptions with the references and the data items with the references for level D. And that then pulls out for level D that we've got these 2 descriptions that are needed. Again, they reference the documents that we need, but also the objective reference within the DO-178C standard that further describes the objectives. So that gives us a very powerful tool for us to use and for the AI to use. Before I get to the conclusion, I'm just going to quickly show you it running. So I'll just switch to a terminal. Now, this is going to interrogate table 7, which is for the verification and validation results. And it's actually going to ask a negative question. I'll just show you the table. It's going to ask what of these objectives is not required for level C, because it's easy to ask what is required. It's a bit more of a test to say what is not required. So it should say that we don't need MCDC, we don't need decision coverage, and we don't need the verification of additional source code. So if I just run this. So it takes table A7, it does the search. In fact, it's been turned into a Python data frame. It comes up with its own query to come up with the answer. It looks like the answer is correct: 5, 6, and 9. And there we go, 5, 6, and 9. So for level C, we do not need MCDC, we do not need decision coverage, and we do not need to verify the source code that cannot be directly traced to the requirements, that we don't have the verification of additional code. So in conclusion, this virtual DER, which has been trained on the DO-178C standard, forms a company-wide store of knowledge. It can answer specific questions and give references that allows an engineer and, crucially, other AI agents. It allows them to determine the appropriate path to achieve objectives in the DO-178C standard. In the next video, I will show this agent being part of a multi-agent solution to do more complex tasks, such as writing the PSAC document or performing an SQA review. My company, Harmonic Software Systems, we use these tools to accelerate and automate the DO-178C process for our customers. So if this is something you're interested in, if you'd like a bigger demo, please get in touch on the contact page. You can book a demo through there. And we've also created a LinkedIn group to discuss AI within the DO-178C framework. You can join us there with that link. In the next video, I will showcase the creation of a PSAC document, but that's it for now. So thank you for the time. Have a great day, and I'll catch you soon.